All. I am Dr. M. Mahalashmi, Assistant Professor, Computer Science Department, Mahalashmi Women's College. I am going to present about Basics of IoT, the Game Changer. Today's presentation is all about birth of IoT, what is IoT, why IoT is required, M2M versus IoT, IoT versus IIoT, what is IoE, life cycle of IoT, physical design of IoT, advantages, disadvantages, real world applications, future of IoT. Birth of IoT. IoT stands for Internet of Things. Was coined by Kevin Ashton in 1999 during his work at Procter and Gamble, initially to promote RFID technology. What is IoT? IoT is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human to human or human to computer interaction. There are various number of IoT definitions. In simple words, IoT is anything and everything connects to internet. IoT is a network of physical objects, people, things that are embedded with the electronics, software, sensors and network that allows these objects to collect and exchange data. It is also referred as M2M, machine to machine, Skynet, IoE, Internet of Everything. It makes everything virtually smart. Interaction between the physical and digital worlds, which is also said to be IoT. In a nutshell, IoT wants to connect all objects to interact with each other on the internet to provide comfort life for human. This simple diagram shows what is IoT, connecting the things together via internet. Lifeline of IoT is internet. Why IoT is required? Flexible configuration, universal internetworking, it has dynamic control, it acts as technology integrator, it provides businesses with a real-time look, environmental monitoring, infrastructure management, and there are variety number of industrial applications. Here M2M versus IoT. Even though we say IoT is referred as M2M, there are few differences. M2M supports point-to-point communication, whereas IoT supports cloud communication. M2M mostly hardware-based technology, IoT supports both hardware and software-based technology. Devices do not necessarily rely on an internet connection in M2M, whereas IoT, I have already told you, lifeline of IoT is internet. Direct communications between machines are required in M2M, but in IoT it is all deals about sensors, automation and internet platform. IoT versus IIoT. IIoT stands for Industrial Internet of Things. Here are a few differences. IoT, it is mainly designated for customers. IIoT, it is used in industries. Security, when we come to security, IoT, it is not an issue when compared to IIoT. But in IIoT, it is major concern because it includes organizations and businesses at large scale. IoT cost is less expensive, but in IIoT, more expensive. In this diagram, we can clearly see Industrial Internet of Things deals with heavy machinery, transportation, smart cities, automation, factories, healthcare. But IoT deals with customers, consumers, that is wearables, phones, TV, smartwatches, home appliances, home monitoring, home automation, all those things. If the things deals with industries, then it is said to be IIoT. If the things deals with customers, then it is said to be IoT. M2M versus IoT versus IoE. M2M I have already discussed. A device that captures an event, transmits it over a network to an application that translates it into a meaningful information. Whereas IoT, a network of uniquely identifiable things that communicate without human interaction. Before discussing about what is IoE, I would like to tell you two more terms, IoD, IoH. What is IoD? Internet of Digital. It deals with smart TV, smartphone, tablet, PCs, all those things. What is IOH? Internet of human wearables, human wearables, smart bands, smart glasses, all those things. So collection of all these things is called IOE, Internet of everything. So what is IOD? Internet of digital. IOH stands for Internet of human. IOT stands for Internet of things. All together is said to be IOE, Internet of everything. Bringing together the people, process, data and things to make networked connections more relevant by turning information into actions. There are 4 basic steps of lifecycle IoT: collect, communicate, analyze, act. Collection of data. Devices or sensors are collecting data everywhere, at your home, in your car, at the office. And second step, communication. Collected data will be sending through networks to some destination via a cloud. It can be a cloud platform or otherwise home network. Third one, analysis. Creating information from the data, visualizing the data, building the reports. And fourth step, action. Take an action based on the information and data, like sending a notification like SMS, email, text to another system. This is very important part in our presentation, IoT architecture. Here you can see sensors, IoT gateways, cloud servers, mobile app. Here sensors or devices collect data from their environment. It could be a temperature or pressure, etc. In simple words, I can say sensors which is able to measure a physical phenomenon like a temperature or pressure, which transforms it into an electrical signal. For example, phone is a device that has multiple sensors like camera, GPS, accelerometer, etc. After collecting a data from the environment using sensors or devices, second step is connectivity. The data is sent to the cloud. Before, if you want to send the data to the cloud, how we can send the data to the cloud? Via cellular, satellite, Wi-Fi, Bluetooth connecting to the internet, which is said to be connectivity, internet gateway or otherwise controller. Third one, data processing. Once the data gets into the cloud, software performs some kind of processing on it. And the fourth step, the information is made useful to the end user in some way. It can be in any kind of alert, email, text or notifications, etc. So in this architecture, what we can see, sensors which will collect the data from their environment. It can be in the form of, it can be temperature, pressure, anything. That can be converted into an electrical signal that will be sent to an connectivity. That is, connectivity means here it is going to connect the sensors to the cloud. So to that connectivity we can make use of Bluetooth, Wi-Fi, all these protocols. And after once the data is collected, the cloud will process the data and then the cloud will produce the data to the users. This is what we have discussed so far, IoT physical design. IoT devices are equipped with embedded sensors, actuators, processors and controllers. About sensors I have already told you, and one more thing I can say, sensors here it is said to be input device. Input device. Few sensor types used by IoT applications. By the name itself we can understand where and all we can use this sensor. There are temperature sensor, proximity sensor, pressure sensor, water quality sensor, chemical, gas, smoke, IR, image, motion detection sensors. So how to select these sensors? There are 3 main criteria: economic, environmental, sensor characteristics. Economic, it all deals about cost, availability and lifetime of the sensor. Environmental, size, how much power it will consume, power consumption, interference and sensitivity. Sensor characteristics, the range of the sensor, stability, is there any error or response time. Sensor communication protocols, or otherwise we can say IoT communication protocols. Using these protocols only we are going to connect to the cloud. And first one is Bluetooth, which we are already familiar about, invented by Jab Hudson. an electrical engineer. In 1994 it has been developed. It connects a variety of headphones and speakers to smartphones and computers. And second, Wi-Fi, which is also already familiar. It is invented by Dr. Sullivan and his colleagues, released in the year 1997. It is wireless LAN technology. And third one, NFC. NFC stands for Near Field Communication. It is invented by Sony and a company called NXP Semiconductors in 2002. It is a set of communication protocols for communication between two electronic devices over a distance of 4 cm or less. It allows wireless data transfer between two portable devices in close proximity. I can say it allows wireless data transfer between two portable devices in close proximity. Here we have 3 C's: connecting, commissioning, controlling. It will connect, then it will communicate, and then it will control the data. That is a major part of NFC. And fourth one is Zigbee. Ember, an American company based in Boston, developed Zigbee in 2005. It is a low-cost, low-power, wireless mesh network standard controls and monitoring application. It covers 10 to 20 meters physical range. It has ZC, ZR, ZED. ZC, Zigbee Coordinator. ZR stands for Zigbee Router. ZED stands for Zigbee End Device. Dear participants, here in this presentation we are discussing only about basics of IoT. So many things are yet to discuss. And next protocol is Z-Wave. It is a wireless communication protocol used primarily for home automation. It is developed by Danish company in 1999. What is MQTT? We are discussing about so many protocols here. These are all the protocols which is used to connect the devices to the cloud. Okay. MQTT, Message Queuing Telemetry Transport. I repeat, Message Queuing Telemetry Transport. It is a lightweight messaging protocol that was first developed by IBM and released in 1999. When we compare to HTTP, as you are aware of, Hypertext Transfer Protocol, MQTT is better than HTTP for sending and receiving data. And next one is AMQP, Advanced Message Queuing Protocol. It is an open source published standard for asynchronous messaging by wire. It is used in client server messaging concept. And there are various features in this: message orientation, queuing, routing, reliability, security, etc. And second one, we are going to discuss about actuators. I repeat once again, already we discussed about, actually we are discussing about IoT architecture. Overview of IoT architecture, I have already told you. Sensors will collect the data from environment. It will send those data. It will convert in the form of electrical signals. Then it will send those data to the cloud via Bluetooth, Wi-Fi, all these protocols. And then cloud will perform the data and then it will reach the users. Right? So here sensors will act like an input device, whereas actuators will act like an output device. Actuators takes an electrical input and it turns it into a physical action. Reverse concept of sensors actually. In sensors, physical data will convert to an electrical part. In actuators, electrical input will convert to a physical action. Example, electric motor, hydraulic system, pneumatic system. These are all the different types of actuators. In that IoT architecture, we have seen gateway, right? We can say it is a controller also. It is the brain of system. It is the brain of IoT. It handles all the number crunching and local data manipulation and decision making. It manages high volumes of continuous data. It is said to be middle tier components that primarily collect information from front end devices. Sum of microcontroller. What are all the microcontrollers we are using in IoT? Already we discussed about what are all the sensors which we can use in IoT, and we discussed about what are all the protocols we can use in IoT, and here we are going to discuss about what are all the microcontrollers we can use in IoT. The famous microcontrollers in IoT are Arduino, Raspberry Pi, Intel Galileo. Okay. Arduino, it is an open source hardware. It is a piece of hardware. It comes with an 80 mega microcontroller that processes the data and facilitates the proper working of the IoT system. It is developed by Massimo Benzi. Whereas Raspberry Pi, it is not a microcontroller, it is a microprocessor. It is developed by Ibn Upton. It is a small credit card based CPU that plugs into a computer monitor or TV. It is low cost and it mostly supports LAN connectivity. Intel Galileo. It is a microcontroller based system. It is the first in a line of Arduino board based on Intel architecture. Hope you all know what is microprocessor and what is microcontroller. Microcontroller, it is a small computer. Microprocessor, it is an electronic component that is used by the computer to do work. So in this concept you can understand Arduino, Arduino means microcontroller. Raspberry Pi, it is not a microcontroller, it is a microprocessor. Intel Galileo is a microcontroller. Advantages of IoT. There are various advantages. It minimizes human efforts. Definitely it minimizes human efforts because IoT interact and communicate with each other without interaction and intervention of human. In first slide itself we have discussed about what is IoT. So it will definitely minimize human effort. Efficient resource utilization. If we know the functionality and the way that how each device works, we definitely increase the efficiency, resource utilization as well as monitor natural resources. Definitely it saves time because it reduces human effort. It enhances data collection and there will be communication, automation and control will be there, information monitoring, and it will save money. Disadvantages. Very important concept: security, privacy, complexity. As the IoT systems are interconnected and communicate over networks, it can lead the various kinds of network attacks. And privacy. Even without the active participation on the user, the IoT system provides substantial personal data in maximum detail. And the complexity. The designing, developing, managing and enabling the large technology to IoT system is quite complicated. Very interesting part of IoT is definitely IoT applications. Home automation, whatnot. Here today in today's digital world, we are using so many things in home itself. So many IoTs are there in a home: AC, fridge, washing machines. So many things. Intelligent alarm is there, smart kitchen, intelligent umbrella, which focus on data science, which work with weather forecasting, bus tracking, smart watches, upcoming smart cities, and smart cities it may deals with air pollution, traffic, light, car parking, etc. Agriculture. Goodnight lamp, this is something different. Here in goodnight lamp, IoT application, what it will do is, it has two lamp. One is primary lamp, another one is secondary lamp. Primary lamp will have switch, whereas secondary lamp will not have a switch. Let us take one small example. Primary lamp is having in child side. Okay, child is in US. Parents are living in India. Child using a lamp in the form of grey color. Parent using lamp in the form of orange color. So why we need this goodnight lamp? If suppose parent from India want to connect child from US, that parent want to know whether our child slept or whether is this right time to call our child or not. So what child can do? The child can switch on the switch. Once the child switch on, automatically it will produce a grey color. So immediately the parents will understand through that good night lamp, the child is ready to speak with the parents. This is one of very famous and very interesting real world IoT applications. So this is what about IoT applications. In home we are using as entertainment, security is a purpose, utilities and home appliances, and we are using in parking field, traffic signals, logistics, and in communities, smart meetings we are using, factories, retail, environment. In national way, we can make it use for infrastructure, defense, smart grid. Industrialists also using IoT. Policymakers can make use of IoT. Doctors can make use of IoT to see patients' health issues, all those things. The game changer, the real game changer is really IoT. Many research says that multiple devices that we use daily life need the internet to serve people. IoT by 2025, according to the projection of the Statista Research Department, 75.44 billion devices will be connected with the worldwide IoT by 2025. 5G. IoT devices will grow from 75 billion to more than 100 billion. More cities definitely will become smart. AI, artificial intelligence, will continue to become a bigger thing. See, smart home hubs, lighting systems, and even coffee makers will collect data on your habits, and it will pattern of your usage. Routers will continue to become more secure and more smarter. Thank you all.